Imagine if something from another star system was racing toward our planet right now. On July 1st, 2025, astronomers made a discovery that sent shockwaves through the scientific community, a mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely. Possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one I Oumuamua and two I Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with 1I Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3I Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific gold mine. Why are astronomers around the world calling 3I/Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I/Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I/Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I/Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that 1I Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I/Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I/Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I/Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3I Atlas, its high velocity and early activity, can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optics systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets. Beneath the Swiss-French border, the world's most powerful machine is unlocking secrets that could reshape reality itself. Did you know the Large Hadron Collider at CERN can recreate conditions a fraction of a second after the Big Bang? That's not just science fiction, it's happening right now, revealing mysteries that have puzzled humanity for centuries. Here's a punchline. Scientists once set out to create a black hole in the lab. Sounds wild, right? But do you know what really happened when they tried? The Big Experiment. Deep beneath the border of Switzerland and France, a machine hums with the energy of 1 billion lightning bolts. The Large Hadron Collider at CERN isn't just another scientific tool, it's the world's most ambitious experiment, designed to answer the deepest mysteries of our universe. Here, scientists accelerate tiny protons to speeds just shy of light itself, then smash them together in a controlled chaos that recreates conditions from the dawn of time. The stakes? Nothing less than rewriting what we know about reality. When the LHC first powered up, the world held its breath. What secrets would these collisions unlock? Could they reveal hidden dimensions, new particles, or even the birth of a black hole right here on Earth? The excitement in the scientific community was electric, matched only by the curiosity, and sometimes fear, of the public. For the researchers, each collision was a chance to glimpse the unknown, to catch a fleeting signal that could change everything. The LHC's detectors, massive and intricate, waited to capture every trace of the subatomic fireworks. Every second, data poured in, flashes of energy, trails of particles, whispers from the fabric of the cosmos itself. This wasn't just about smashing atoms, it was about pushing the boundaries of human knowledge. The world's brightest minds gathered at CERN, united by one goal, to unlock the secrets of existence, one collision at a time. And on that day, as the LHC roared to life, the stage was set for a discovery that could shake the universe. The black hole theory. Rumors swirled as whispers of black holes at CERN hit headlines, sparking debates from classrooms to coffee shops. The idea wasn't science fiction, it was rooted in real physics. Some theorists proposed that the extreme energies inside the Large Hadron Collider could momentarily create microscopic black holes, so tiny they'd vanish in a flash. These wouldn't be the monstrous cosmic beasts devouring stars, but subatomic blips, lasting less than a heartbeat. The theory was electrifying. If these mini black holes appeared, they could offer clues about hidden dimensions and the true nature of gravity. For physicists, the possibility was a golden ticket to test ideas that had only existed on chalkboards and in computer simulations. The world's media, though, latched onto the word black hole with a mix of fascination and fear. Headlines warned of doomsday scenarios while scientists calmly explained the math. Any black hole produced would evaporate instantly, harmlessly, thanks to a process called Hawking radiation. Still, the buzz was unstoppable. People wanted to know, could humanity really create a black hole, even for a split second? The tension between groundbreaking discovery and public anxiety gave the experiment an edge of drama rarely seen in science. As the countdown to the first collisions ticked down, all eyes were on CERN, waiting to see if the wildest theories in physics would leap from the pages of textbooks into reality, even if only for the briefest moment. Public panic. The world watched with a mix of awe and anxiety, as news outlets ran wild with headlines about CERN potentially creating a black hole. Social media feeds exploded with speculation, fueling a frenzy that reached far beyond the walls of any laboratory. Parents worried about their children's future, conspiracy theorists spun tales of impending doom, and even some scientists found themselves fielding questions from concerned friends and family. Petitions began circulating online, gathering thousands of signatures from people demanding the experiment be stopped. Lawsuits were filed in international courts, arguing that humanity was on the brink of unleashing a catastrophe it couldn't control. The debate wasn't just confined to science journals, it became dinner-table conversation, late-night talk show fodder, and the subject of heated arguments on radio and TV. The tension was palpable, and for many, the line between scientific possibility and science fiction seemed to blur. Yet, amid the chaos, CERN's researchers remained focused, determined to separate fact from fear. They addressed the public's concerns head-on, holding press conferences and releasing detailed safety reports. Their message was clear, the science was solid, and the risks were virtually non-existent. But the spectacle of public panic had already taken on a life of its own, transforming a groundbreaking scientific endeavor into a global drama. As the countdown to the first collisions continued, the world held its breath, gripped by a mixture of curiosity, skepticism, and a dash of existential dread. The science behind it. Physicists at CERN knew the stakes were high, not just for science, but honestly, for public trust as well. As the world's attention zeroed in on the collider, experts really stepped up to explain the real science behind the headlines. The idea of creating a black hole in the lab was rooted in advanced theories, but the reality was, well, far less dramatic than the doomsday scenarios suggested. According to the mathematics of Stephen Hawking, any microscopic black hole that might form would evaporate in a fraction of a second, releasing its energy harmlessly back into the universe. This process, known as Hawking radiation, meant that even if the collider succeeded in producing these elusive objects, they'd vanish before they could do anything at all. Scientists published extensive safety reviews, showing that cosmic rays, natural high-energy particles from space, strike Earth's atmosphere with far more energy than anything produced at CERN, and have been doing so for billions of years without any catastrophic consequences. The reassurance didn't stop the questions, but it did offer a foundation of calm in the midst of the storm. Researchers used every tool at their disposal, public lectures, interviews, and open days at the laboratory, to demystify their work and invite the public into the process. Their message was consistent. The quest for knowledge is never without risk, but the safeguards were robust, and the science was sound. For those who listened, the fear began to fade, replaced by a sense of wonder at the boldness of human curiosity. The moment of truth. Pressure built inside the control room as the countdown ticked closer to zero. Every scientist glued to their monitors, every eye scanning for the slightest anomaly. The world outside buzzed with anticipation, but inside CERN, focus was absolute. Years of planning, debate, and preparation all led to this moment. The first high-energy collision inside the Large Hadron Collider. Protons, accelerated to near light speed, hurtled toward each other in a tunnel colder than deep space. The instant they collided, a burst of energy erupted, brief, brilliant, and packed with the potential to reveal the universe's hidden layers. Detectors as tall as buildings and packed with cutting-edge technology snapped into action, capturing every trace, every spark, every whisper of something extraordinary. Scientists watched the data stream in, looking for any sign, a deviation, a flash, a particle signature that might hint at the creation of a microscopic black hole. The tension was electric, every second stretching into eternity as the world waited for news. Would the experiment confirm decades of theory, or rewrite the rules of physics altogether? The stakes were enormous, not just for the researchers but for everyone watching. In that instant, the boundaries between fear and fascination blurred, and the pursuit of knowledge took center stage. The world was about to find out if the universe would reveal one of its greatest secrets or if the mysteries would remain just out of reach. What the detectors saw. A surge of anticipation swept through the data centers as the first collisions unfolded, unleashing a torrent of information that only the most advanced detectors on Earth could decode. Scientists huddled around screens, eyes darting between streams of numbers and vivid bursts of color, each one a potential clue to something extraordinary. The detectors, engineered to capture the faintest traces of subatomic chaos, registered a symphony of particles and energy signatures. Flashes of exotic matter, fleeting and rare, danced across the monitors, each event meticulously catalogued and analyzed. But among the fireworks of quantum debris, there was no sign of a stable black hole, no gravitational anomaly, no runaway reaction. Instead, the readings matched the predictions: bursts of energy, showers of particles, but nothing that threatened to spiral out of control. The absence of disaster was, in itself, a triumph. Every blip and spike in the data told a story, confirming that the universe's rules held firm, even under the most extreme conditions humans could create. The experiment's outcome reassured not just the scientists, but a world that had been holding its breath. As the data poured in, it became clear that the LHC was not a harbinger of doom, but a gateway to deeper understanding. The detectors had witnessed the universe at its most fundamental, and what they saw was both expected and astonishing, a testament to the power of human curiosity and the precision of modern science. The unexpected discovery. What truly stunned the scientific community wasn't the arrival of a black hole, but rather the treasure trove of rare particle interactions that emerged from the chaos. As the detectors sifted through trillions of collisions, they began to reveal patterns and phenomena that had never been observed before. Among the swirling clouds of subatomic debris, researchers spotted fleeting traces of particles predicted by theory but never caught in action. Exotic combinations that pushed the boundaries of quantum physics. These discoveries weren't just statistical blips, they were windows into realms of matter and energy that had only existed in equations and speculation. Every new interaction, every anomalous signal, became a potential breakthrough, sparking debates and excitement across the globe. The LHC's ability to recreate these extreme conditions allowed scientists to probe the very fabric of reality, inching closer to answers about the universe's most profound mysteries. The unexpected findings fueled a surge of innovation, inspiring new experiments and theories that rippled through the world of physics. For the researchers at CERN, each surprise in the data was a reminder that the universe still held secrets waiting to be uncovered. The absence of a black hole didn't mean disappointment. Instead, it marked the beginning of a new chapter in discovery, where the unknown beckoned with even greater promise and wonder. Media frenzy. Wow, what a whirlwind it was! Newsrooms scrambled to keep up as the story of CERN's black hole experiment exploded across headlines, turning a scientific milestone into a global sensation. The media, always hungry for drama, seized on every possibility. Some outlets painted the experiment as a bold leap for humanity, while others stoked fears with talk of doomsday scenarios and runaway black holes. Social media platforms became battlegrounds of opinion, with hashtags trending worldwide and heated debates erupting in comment sections. Scientists suddenly found themselves thrust into the spotlight, fielding interviews and answering rapid-fire questions from reporters eager for a soundbite. The narrative shifted almost hourly, swinging between awe at the scale of human achievement and anxiety over the unknown. For many viewers, the spectacle was irresistible, a real-life science thriller unfolding in real time, with the fate of the planet seemingly hanging in the balance. Yet behind the scenes, researchers worked tirelessly to cut through the noise. offering clear explanations and sharing real-time updates to keep the facts front and center. Their transparency helped calm the storm, but the media frenzy had already cemented CERN's experiment as one of the most talked-about scientific events of the decade. The world was hooked, not just on the possibility of black holes, but on the drama, the debate, and the sheer audacity of exploring the universe's deepest mysteries. Scientific legacy. And so, long after the first collisions, the true legacy of CERN's bold experiment began to take shape, not in disaster, but in the seismic shift it sparked across the scientific world. The fears of black hole catastrophes faded into the background as the LHC's results fueled a new era of discovery. Among its greatest triumphs was the confirmation of the Higgs boson, the elusive God particle that gave mass to everything in the universe. This breakthrough alone redefined the boundaries of particle physics and earned a Nobel Prize, but the impact didn't stop there. The data collected from the collider's experiments opened doors to questions about dark matter, antimatter, and the very forces that hold the cosmos together. Researchers across the globe dove into the treasure trove of findings, designing new experiments and refining theories that had been debated for decades. The LHC became a symbol of what humanity could achieve when curiosity and collaboration took center stage. Its experiments not only silenced the doomsayers, they inspired a new generation of scientists, engineers and dreamers to push further and dig deeper. The legacy of CERN's black hole quest is written not in fear, but in the relentless pursuit of knowledge and the breakthroughs that continue to ripple through the world of science, reshaping our understanding of the universe with every passing year. The ongoing quest. But curiosity refuses to rest, and at CERN, the quest for answers only grows more ambitious with every passing year. The Large Hadron Collider, once the subject of global suspense, now stands as a launchpad for even bolder experiments. Researchers are ramping up the energy, refining their detectors and dreaming bigger than ever, hoping to uncover new particles, forces, or perhaps even cracks in the very laws of physics. Each experiment is a leap into the unknown, a calculated risk that could unlock secrets about dark matter, quantum realms, or the origins of the universe itself. The excitement in the halls of CERN is contagious, fueled by the knowledge that every breakthrough, no matter how small, brings humanity closer to understanding the fabric of reality. The world watches with anticipation, eager for the next headline, the next discovery that could reshape textbooks and challenge what we think we know. For the scientists, the journey is as thrilling as the destination, a relentless pursuit of knowledge that transforms fear into fascination and speculation into science. The story of CERN's black hole experiment isn't over. It's just the opening chapter in a saga of exploration that promises to keep pushing the boundaries of what's possible, inspiring curiosity and wonder in generations yet to come. Thanks for joining me on this wild journey into the mysteries of CERN and black holes. If you enjoyed exploring the unknown with Space Facts, make sure to hit that subscribe button and ring the bell icon so you never miss our next cosmic adventure. I'd love to hear your thoughts. Drop a comment below and let me know what space fact blew your mind today. Your support helps us keep bringing you the universe's most fascinating secrets. Until next time, keep looking up and stay curious. An object from beyond our sun barreled through the inner solar system on October 19, 2017, moving so fast it couldn't possibly have come from here. Astronomers named it Oumuamua, messenger from afar, and soon realized its brightness was flipping tenfold every 8 hours, hinting at a shape unlike any natural body we've ever seen. Oumuamua initial detection. A cosmic intruder just crashed our solar system's private party, and it came from another star. On October 19, 2017, astronomer Robert Warwick was scanning telescope data at the University of Hawaii when he spotted something that shouldn't exist, a fast-moving object that didn't belong to our neighborhood. The Pan-STARRS 1 telescope had captured humanity's first glimpse of an interstellar visitor, something that had traveled for millions of years through the void between stars just to reach us. What made this discovery so extraordinary wasn't just the object itself but the incredible timing. Scientists estimate that only one interstellar object passes through our solar system every few years, and most are just too small or too fast to detect. Scientists quickly realized this wasn't space junk or a rogue asteroid from our own system. The trajectory was all wrong, the speed was incredible, and the direction it came from pointed to deep space. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, because it truly was our first confirmed messenger from another star system. The discovery process itself was remarkable. Werik initially thought it might be an error in the data until he tracked the object across multiple images. Within days of discovery, telescopes around the world were frantically tracking this mysterious visitor as it raced through our solar system at 26 kilometers per second. The Minor Planet Center in Cambridge immediately issued alerts to observatories worldwide, triggering an unprecedented international collaboration. The object was already past its closest approach to the Sun and heading back into interstellar space, giving scientists only a brief window to study it before it disappeared forever into the cosmic dark. What they found would challenge everything we thought we knew about space rocks, comets, and the possibility that we might not be alone in the universe. This cosmic messenger was about to rewrite the textbooks and spark debates that continue today. Classification challenges. Scientists love putting things in neat categories, but Oumuamua refused to play by the rules and turned astronomical classification into chaos. Initially classified as Comet C/2017 U1 on October 25, 2017, researchers expected to see the classic signs: a glowing tail, a fuzzy coma of gas and dust as ice sublimated near the Sun. Comets are essentially dirty snowballs that light up beautifully as they approach our star, creating spectacular displays that have inspired humans for millennia. But Oumuamua was having none of it. No tail, no coma, no visible outgassing whatsoever, even though it had passed closer to the Sun than Mercury's orbit. This was like expecting a snowball to melt in a furnace and finding it completely unchanged. Confused astronomers quickly reclassified it as Asteroid A/2017 U1, but that didn't feel right either. Traditional asteroids are rocky or metallic chunks left over from planetary formation, and they follow predictable patterns based on billions of years of observation. But Oumuamua's behavior was inconsistent with known asteroid properties. Its rotation rate, brightness variations, and movement patterns all suggested something fundamentally different. By November 2017, the International Astronomical Union faced an unprecedented problem and created an entirely new classification system just for Oumuamua, designating it 1I/2017 U1, the I standing for Interstellar. This was the first time in astronomical history that a completely new category had to be invented for a single object, highlighting just how unprepared science was for visitors from other star systems. The classification headache revealed something profound. Our understanding of cosmic objects was based entirely on things that originated in our solar system, shaped by our sun's gravity and radiation over 4.6 billion years. Oumuamua was playing by different rules written in another star system billions of years ago under completely different conditions. Its refusal to fit into existing categories was the first hint that this visitor was unlike anything we'd ever encountered. And scientists began to realize they weren't just looking at a space rock, they were examining an alien artifact from deep space. Trajectory analysis. Tracking Oumuamua's path through space was like following breadcrumbs back to another world, and the story it told was absolutely mind-blowing. Astronomers used precise measurements from observatories worldwide, including the Very Large Telescope in Chile and the Gemini Observatory in Hawaii, to reconstruct its journey with incredible accuracy. What they found was a cosmic wanderer that had been drifting through interstellar space for millions of years before accidentally stumbling into our solar system like a lost traveler finding civilization. Dr. Marco Micheli and his team at the European Space Agency traced its origin to the general direction of the constellation Lyra, specifically toward the star Vega, one of the brightest stars in our night sky. But here's the incredible part. Even if it came directly from Vega, it would have taken 600,000 years to make the journey, meaning this object began its voyage when early humans were just learning to control fire. The trajectory analysis revealed that Oumuamua wasn't bound to any particular star system. It was a true galactic wanderer that had been drifting through the local standard of rest, the average motion of stars in our galactic neighborhood. The object entered our solar system from above the plane where planets orbit, approaching at a steep 122-degree angle that no local object could achieve. This approach angle was like a cosmic signature proving its interstellar origin beyond any doubt. Its hyperbolic trajectory meant it was moving too fast to be captured by the sun's gravity. This was a true flyby mission with no possibility of return. The orbital calculations revealed Oumuamua came within 0.25 astronomical units of the Sun on September 9, 2017, closer than Mercury's orbit, experiencing temperatures of over 300 degrees Celsius before being flung back toward interstellar space by gravitational slingshot effects. By the time astronomers discovered it in October, it was already racing away at 44 kilometers per second relative to the Sun, fast enough to travel from Earth to the Moon in just over 2 hours. The trajectory analysis proved beyond doubt that this was our first confirmed visitor from another star system, a cosmic time capsule that had witnessed the birth and death of distant worlds, survived the radiation of interstellar space, and arrived at our doorstep carrying secrets from the galaxy beyond. Photometry and shape analysis. So, photometry and shape analysis showed that Oumuamua was doing something no space rock should do. It was flashing like a cosmic lighthouse. Photometric observations from multiple telescopes revealed that the object's brightness varied by an extraordinary factor of 10 every 7.3 hours as it tumbled through space. This dramatic brightness change suggested something unprecedented, an object so elongated that it was unlike anything in our solar system. Dr. Karen Meach from the University of Hawaii led the analysis, calculating that Oumuamua was at least 10 times longer than it was wide. Imagine a cosmic cigar, or maybe a football spinning end over end. Some models even suggested it could be more extreme, possibly a 20-to-1 length-to-width ratio. But Dr. Sergei Mushchenko proposed an alternative. What if it wasn't cigar-shaped but pancake-shaped? A flat, disc-like object could also produce the same brightness variations. The tumbling period was unusual too. Most asteroids rotate much faster, but Oumuamua's leisurely spin suggested it might be held together by something other than typical rocky materials. The photometric data painted a picture of an object so bizarre that it challenged our understanding of how planetary formation works. No known process in our solar system creates objects with such extreme dimensions. This wasn't just unusual, it was honestly geometrically impossible, according to everything we knew about how gravity shapes space rocks. Oumuamua was, in a sense, rewriting the rules of cosmic architecture. Acceleration anomaly. And then, there was the acceleration anomaly. Oumuamua just broke physics, and scientists are still trying to figure out how. As telescopes tracked the object's movement away from the Sun, something impossible happened. It started accelerating faster than gravity alone could explain. Dr. Marco Michelli's team at ESA first detected this non-gravitational acceleration in June 2018, analyzing data from the Hubble Space Telescope and ground-based observatories. The acceleration was tiny, only about 0.00005 meters per second squared, but it was real and measurable. For comparison, if you dropped a feather and it fell upward instead of down, that would be less surprising than what Oumuamua was doing. In our solar system, when objects accelerate away from the Sun without gravitational explanation, it's usually because they're comets releasing gas and dust that creates a rocket-like thrust. But Oumuamua showed no signs of such outgassing. No tail, no coma, nothing visible that could explain the extra push. The acceleration was also pointing in exactly the right direction, directly away from the Sun, which made it even more mysterious. Professional astronomers ran the calculations dozens of times, checked their instruments, and consulted with colleagues worldwide. The result was always the same. Oumuamua was being pushed by an invisible force. This single observation transformed a curious interstellar visitor into one of the most puzzling objects ever detected, launching 1,000 scientific theories and capturing the imagination of anyone who wondered if we might not be alone. Spitzer observations. NASA brought out the big guns to solve the Oumuamua mystery, and what they found made everything more confusing. The Spitzer Space Telescope, with its incredibly sensitive infrared detectors, was humanity's best hope for detecting any invisible outgassing that might explain the object's mysterious acceleration. Dr. David Trilling from Northern Arizona University led the observations in November 2017, pointing Spitzer's instruments at Oumuamua as it raced away from the inner solar system. Infrared telescopes can detect heat signatures from sublimating ice and microscopic dust particles that are completely invisible to optical telescopes. If Oumuamua was secretly behaving like a comet, Spitzer would catch it red-handed. The results were published in the Astronomical Journal in 2018, and they were as puzzling as they were definitive. Nothing. Absolutely nothing. Spitzer's upper limits on dust and gas production were so strict that they ruled out traditional cometary activity by orders of magnitude. If Oumuamua was releasing material to create thrust, it was doing so at levels 10,000 times lower than typical comets. This wasn't just unusual, it was physically implausible. The Spitzer observations eliminated the most obvious explanation for the acceleration anomaly and forced scientists to consider more exotic possibilities. Either Oumuamua was made of materials that don't exist in our solar system, or it was being pushed by forces that we don't understand, or, well, it wasn't natural at all. Artificial origin hypothesis. So here's the thing. Harvard astronomer Dr. Avi Loeb dropped a scientific bombshell that made headlines worldwide and honestly divided the astronomy community. Back in October 2018, Loeb and his postdoc Dr. Shmuel Bialy published a paper suggesting that Oumuamua might not be a natural object at all, it could actually be artificial technology created by an alien civilization. Their hypothesis, which was published in the Astrophysical Journal Letters, proposed that Oumuamua was a light sail, an ultra-thin sheet of material designed to be pushed by radiation pressure from stars. This idea would explain both its unusual shape and the mysterious acceleration, without needing any detectable outgassing. And, light sails are real technology that humans are developing for interstellar missions, so the physics behind it was actually sound. Loeb calculated that an object only millimeters thick, but hundreds of meters wide could behave exactly like Oumuamua, accelerating away from the sun as starlight pushed against its surface. The paper, as you might imagine, sparked fierce debate in the scientific community. Critics argued that invoking alien technology violated Occam's razor, the principle that simpler explanations are usually correct. But Loeb countered that the scientific method requires considering all possibilities, even the uncomfortable ones. His 2021 book Extraterrestrial further developed this hypothesis, arguing that scientists' reluctance to consider artificial origins was more about sociology than science. Whether he's right or wrong, Loeb's proposal really forced astronomers to think outside conventional boundaries and consider that our first interstellar visitor might have been our first contact with alien engineering. Dark comet theory. So scientists found a kind of middle ground between the idea of a normal space rock and the more far-out theory of an alien spacecraft, and it's called the dark comet hypothesis. Dr. Daryl Seligman from the University of Chicago, along with his colleagues, actually proposed back in 2019 that Oumuamua belonged to a previously unknown class of objects that behave a lot like comets, but basically remain invisible to us. These so-called dark comets would have just enough ice to create the non-gravitational acceleration we saw, through a process called sublimation, but at levels so low that our instruments just couldn't pick up the outgassing. The theory suggested that Oumuamua was made of materials that had been altered by billions of years of exposure to cosmic radiation out there in interstellar space. This kind of space weathering could create a dark, carbon-rich crust that would hide any ice underneath and make the object look a lot more like an asteroid than a comet. Computer simulations even showed that tiny amounts of sublimating hydrogen gas, basically invisible to most telescopes, could produce exactly the kind of acceleration that was observed. The dark comet model explained Oumuamua's behavior without needing to invoke exotic physics, or, alien intervention. It also suggested that interstellar space might actually be filled with these mysterious objects, failed comets, planetary fragments, or debris from destroyed worlds that have been wandering between the stars for eons. The hypothesis gained even more credibility when astronomers began finding similar objects right here in our own solar system. Small bodies with mysterious accelerations but no visible outgassing. So, Oumuamua might not be unique after all, maybe it's just the first representative of a hidden population of dark wanderers that populate the galaxy. Dark comet classification. The mystery of Oumuamua got even more interesting when astronomers started spotting similar objects basically hiding in plain sight within our own solar system. In 2023, Dr. Daryl Seligman and his team published some pretty groundbreaking research identifying 7 near-Earth objects that showed the same puzzling behavior: non-gravitational acceleration without any visible outgassing. These objects, now officially classified as dark comets, provided the missing link in understanding Oumuamua's true nature. The research published in the journal Icarus actually revealed 2 distinct populations of dark comets in our solar system. outer dark comets like 2003 RM and 2010 BK118 follow eccentric orbits similar to traditional comets but show no visible activity. Inner dark comets, like 2007 VA85, orbit closer to the Sun and tend to be smaller, which suggests different formation mechanisms or evolutionary histories. This discovery was honestly revolutionary because it meant dark comets weren't just rare interstellar oddities. They were a previously unrecognized population that had been masquerading as asteroids for decades. The new classification system distinguished them from regular comets and asteroids based on their orbital dynamics and the lack of any detectable coma or tail, despite clear evidence of non-gravitational forces at work. Finding dark comets in our own solar system strongly supported the idea that Oumuamua belonged to this category. It suggested that these kinds of objects might actually be common throughout the galaxy. Invisible wanderers moving between star systems, maybe even carrying ice and organic materials that could seed life on distant worlds. The dark comet classification really transformed Oumuamua from a unique anomaly into the first confirmed member of a whole cosmic population we never even knew existed. Scientific debate. 5 years after Oumuamua's flyby, the scientific community is still, well, fascinatingly divided. And that's actually how science should work. Multiple competing theories keep battling it out in peer-reviewed journals, with each one having some pretty compelling evidence and passionate supporters. The mainstream scientific consensus has gradually shifted toward the dark comet explanation, with researchers like Dr. Jennifer Bergner from the University of California, Berkeley publishing detailed models in 2023, showing how hydrogen outgassing could explain every observed characteristic of Oumuamua. Meanwhile, Dr. Avi Loeb continues to push for the artificial origin hypothesis, launching the Galileo project to search for similar objects and develop new detection methods for potential techno-signatures. Some conservative astronomers prefer explanations involving exotic but natural processes. Maybe Oumuamua was a fragment of a nitrogen iceberg from a Pluto-like world, as Dr. Alan Fitzsimmons proposed back in 2021. The debate has actually produced over 200 scientific papers since 2017, each one adding new pieces to the puzzle. What makes this controversy especially valuable is that it's driving innovation in observational astronomy and interstellar object detection. Projects like the Vera Rubin Observatory, which is set to begin operations in 2024, will discover hundreds of interstellar visitors in the coming decade. The European Space Agency's proposed Comet Interceptor mission could even rendezvous with the next Oumuamua-like object. No matter which theory ends up being correct, Oumuamua has fundamentally changed our perspective on the solar system's place in the galaxy, and reminded us that the universe still holds some pretty profound mysteries waiting to be solved. Alright, that's a wrap on Oumuamua's mind-bending mystery. This interstellar visitor really challenged everything we thought we knew about space objects and honestly left us with more questions than answers. Was it a dark comet, alien technology, or something else entirely? The truth is still out there, just waiting to be discovered. So, what do you think Oumuamua really was? Drop your theories in the comments below. I actually read every single one. And hey, if you're hungry for more cosmic mysteries and space facts that'll totally blow your mind, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries. The universe is full of secrets, and we're just getting started uncovering them together here at Space Facts. While NASA and SpaceX dominate today's headlines about Mars exploration, the most daring attempts to reach the Red Planet happened 60 years ago behind the Iron Curtain. The Soviet Union launched secret Mars missions that were so advanced, so ambitious, and so catastrophically dangerous that, honestly, they make Elon Musk's Starship look like a neighborhood science project. These missions literally exploded on launch pads, crashed into alien soil, and vanished into cosmic silence. But they paved the way for everything we know about interplanetary travel today. Did you know the Soviets actually landed on Mars before anyone else, but it was completely by accident? The beginning. While everyone was obsessed with the moon landing in 1969, the Soviet Union was quietly plotting something far more audacious, a mission to Mars that would make Apollo 11 look like a neighborhood joyride. The space race wasn't just about planting flags on lunar soil, it was about who could conquer the ultimate prize, the Red Planet. Behind the Iron Curtain, Soviet engineers were designing spacecraft that could travel 140 million miles through the cosmic void, endure radiation storms, and attempt humanity's first landing on another world. This wasn't science fiction, this was Cold War reality. While Neil Armstrong was taking his famous first steps, Soviet mission planners were already calculating launch windows to Mars, designing heat shields that could survive atmospheric entry at 12,000 miles per hour, and developing communication systems that could beam signals across interplanetary distances. The Soviet space program had already shocked the world with Sputnik in 1957, and Yuri Gagarin's historic flight in 1961, but their Mars ambitions were on an entirely different scale. These weren't just orbital missions or lunar flybys, they were attempting to land functional spacecraft on a planet where temperatures swing from 70 degrees Fahrenheit to minus 195 degrees Fahrenheit, where dust storms can rage for months, and where one miscalculation means losing everything in the dark expanse of space. What happened next would change everything we thought we knew about the space race, and most of the world never even heard about it. Mars 1. A single radio signal from 140 million miles away changed everything, and then went silent forever. On November 1, 1962, the Soviet Union launched Mars 1, an 894-kilogram metallic behemoth packed with cameras, spectrometers, and enough scientific instruments to revolutionize our understanding of the Red Planet. This wasn't just another satellite circling Earth. This was humanity's first serious attempt to reach another world, and the Soviets were betting everything on it. The spacecraft was a marvel of 1960s engineering, solar panels that could function in the weak sunlight beyond Earth's orbit, a communication system designed to transmit data across interplanetary distances, and a heat shield capable of surviving the brutal journey through space. For 106 days, Mars 1 hurtled through the cosmic void, its trajectory perfectly calculated to intercept Mars during its 1963 closest approach to Earth. Soviet engineers monitored every signal, every telemetry reading, as their creation became the first human-made object to venture into deep space with a specific destination in mind. The mission was so classified that even NASA didn't fully understand what the Soviets had achieved until years later. But on March 21, 1963, at a distance of 65.9 million miles from Earth, Mars 1 transmitted its final signal, a weak radio pulse that faded into the cosmic silence. Radio Moscow never officially announced the mission's failure, but behind closed doors, Soviet scientists knew they had lost their first ambassador to Mars somewhere in the vast darkness between worlds, carrying with it humanity's first real dreams of interplanetary exploration. Mars 2. Two identical spacecraft sat on launch pads 3,000 miles apart, each carrying humanity's most sophisticated interplanetary technology, and both were about to become monuments to cosmic ambition and earthly miscalculation. The Soviet Union's Mars 1969A and Mars 1969B missions represented the pinnacle of Cold War space engineering, featuring advanced panoramic cameras, soil analysis equipment, and atmospheric sensors that could have rewritten textbooks about planetary science. These weren't simple flyby missions like their predecessor. These bus-sized spacecraft were designed to actually land on Mars and transmit the first close-up images of the Martian surface back to Earth. Soviet engineers had spent 3 years perfecting every component, from the retro rockets that would slow the descent to the shock-absorbing legs, designed to cushion impact on alien soil. The timing was critical. Mars and Earth aligned favorably for interplanetary travel only once every 26 months, and the Soviets knew NASA was preparing their own Mars missions for the same launch window. On March 27, 1969, technicians began the final countdown for Mars 1969A at Baikonur Cosmodrome. The 4-stage Proton-K rocket stood 190 feet tall, its liquid oxygen and kerosene fuel tanks pressurized and ready. At exactly 10:40 Moscow time, the engines ignited with a roar that could be heard 20 miles away. For 51 seconds, everything went perfectly. The rocket climbed steadily through Kazakhstan's morning sky. Then, in an instant that would haunt Soviet space officials for decades, the entire assembly disintegrated in a fireball so massive it registered on seismographs across Central Asia. Mars 1969. The shockwave shattered windows 15 miles away, and in that single catastrophic moment, the Soviet Union lost not just a spacecraft, but their best chance at beating America to Mars. What should have been the triumphant launch of Mars, 1969A instead became one of the most spectacular and most covered-up disasters in space exploration history. The Proton K rocket had barely cleared the launch tower when its third stage suffered a catastrophic engine failure, turning 500 tons of rocket fuel into an airborne inferno that painted the Kazakh sky orange for 37 seconds. Soviet officials immediately declared a media blackout. No photographs, no news reports, no acknowledgement that anything had even happened. But you can't hide an explosion visible from orbit. American spy satellites captured the entire sequence, watching as debris rained down across a 50-square-mile area of the Baikonur Cosmodrome. The blast crater measured 200 feet across and 30 feet deep, and radioactive fuel contaminated the launch pad for months. More devastating than the physical destruction was what burned up in that fireball. 7 years of Soviet Mars program development, millions of rubles in cutting-edge technology, and the careers of dozens of rocket engineers who were quietly reassigned to other projects. The backup mission, Mars 1969B, was indefinitely postponed as investigators sifted through the wreckage, trying to understand how their most reliable rocket had become a 3,000-degree funeral pyre for humanity's Martian dreams. Leonid Brezhnev himself reportedly watched footage of the disaster and declared that Mars missions were too dangerous to continue. Mars 1971. Against all odds and political pressure, Soviet engineers refused to surrender their Martian dreams. And on May 19, 1971, they launched what would become both their greatest triumph and most heartbreaking near miss in space exploration history. Mars 2 lifted off from Baikonur with the weight of the entire Soviet space program on its shoulders, carrying not just scientific instruments, but the redemption of a nation's cosmic ambitions. This time, everything went flawlessly. The Proton K rocket performed perfectly. The trajectory calculations were precise to within 0.001 degrees, and for 193 days, the spacecraft hurtled through space toward its December rendezvous with the Red Planet. Soviet Mission Control tracked every signal as Mars 2 became the first human-made object to successfully reach Martian orbit and deploy a functional lander. The 1,210-kilogram descent module separated perfectly, its heat shield glowing white-hot as it slammed into the Martian atmosphere at 13,000 miles per hour. But Mars itself had other plans. A planet-wide dust storm, the largest ever recorded, had been raging for months, turning the entire Martian surface into an impenetrable orange hurricane. The lander's parachute system couldn't compensate for the chaotic atmospheric conditions, and instead of the gentle touchdown Soviet scientists had dreamed of, Mars 2 crashed into the Christ-Planitia region at terminal velocity. In that devastating impact, the Soviet Union achieved a bitter milestone. They had successfully delivered the first human artifact to Mars, but it was now scattered across several square miles of alien terrain, silent forever. Mars earthquakes. The red planet is literally shaking itself apart, and the seismic data is so terrifying that NASA scientists are rewriting everything they thought they knew about planetary geology. On May 4, 2022, NASA's InSight lander detected something unprecedented, a magnitude 5.0 Marsquake that lasted over 6 hours and released energy equivalent to 32 billion joules, enough power to supply a small city for an entire day. This wasn't just another minor tremor, it was the most powerful seismic event ever recorded on another planet, and it revealed that Mars is far more geologically active than anyone imagined. InSight's ultra-sensitive seismometer had been listening to the planet's heartbeat for 1,318 Martian days, recording over 1,300 smaller Marsquakes, but this monster event shattered all previous records. The quake originated deep within Mars's interior, possibly from the Cerberus Fossae region, a network of massive fractures that stretch for thousands of miles across the planet's surface. What's truly mind-blowing is that Mars lacks the tectonic plates that cause earthquakes on Earth, meaning these violent tremors are generated by something else entirely. The planet's core is cooling and contracting, causing the entire Martian crust to crack like a drying mud puddle. French seismologist Philippe Lognon described the data as absolutely extraordinary, revealing that Mars experiences daily seismic activity that would terrify geologists if it happened on Earth. These discoveries completely overturn the old assumption that Mars is a geologically dead world, proving instead that it's a dynamic, evolving planet where the ground literally moves beneath your feet. Mars subsurface lakes. Buried beneath a mile of frozen Martian ice lies something that could, well, totally rewrite the search for extraterrestrial life. Liquid water lakes so vast they actually dwarf the Great Lakes, and they've been hiding there for millions of years. In 2018, Italian planetary scientist Roberto Orosai made a discovery that honestly sent shockwaves through the scientific community. Using radar data from the European Space Agency's Mars Express orbiter, his team detected a 12-mile-wide underground lake beneath Mars's south polar ice cap. This wasn't just frozen water or trace moisture. This was actual liquid water, maintained in its fluid state by a combination of geothermal heat from the planet's core and high salt concentrations that act like cosmic antifreeze. The radar penetration revealed what looks like a subglacial lake system, similar to those found beneath Antarctica's ice sheets, where Earth's most extreme organisms thrive in complete darkness. But here's where it gets truly extraordinary. Follow-up studies using Marcius radar discovered not just one lake, but an entire network of interconnected water bodies spanning hundreds of square miles beneath the Martian polar regions. Orosai's team published their findings in Science magazine, describing radar signatures so clear they're unmistakable. The bright reflections can only come from liquid water interfaces. These subsurface oceans have remained liquid for potentially billions of years, protected from Mars's hostile surface by thick ice and sustained by planetary heat. If life ever existed on Mars, these hidden lakes represent its last refuge, dark, salty sanctuaries where Martian microorganisms might still be thriving right now, completely unaware that curious humans are 140 million miles away, planning missions to drill down and say hello. Mars organic matter. The Martian soil is literally crawling with the building blocks of life, and the evidence is so overwhelming that NASA scientists are frantically recalibrating their entire approach to the search for extraterrestrial organisms. On September 15, 2022, NASA's Perseverance rover made a discovery that sent ripples through the astrobiology community. Organic compounds embedded within Martian rock samples from the Jezero crater, a 28-mile-wide ancient lake bed that once held liquid water for millions of years. These aren't just trace amounts of carbon. We're talking about complex organic molecules including aromatic compounds and aliphatic chains that form the fundamental chemistry of life as we know it. Perseverance's Pixel instrument detected these compounds using X-ray imaging and spectroscopy, revealing organic concentrations 10 times higher than anything previously found on Mars. NASA astrobiologist Amy Williams described the findings as unprecedented, noting that the organic matter is preserved within sedimentary rocks that formed when Jezero crater was a thriving ancient lake ecosystem. What makes this discovery truly extraordinary is the variety and complexity of the organic compounds. They're not random carbon molecules but structured chemicals that could only form under specific environmental conditions. The rover's samples contain nitrogen-bearing organics, sulfur compounds, and hydrocarbon chains that mirror the chemical signatures found in Earth's oldest fossils. Thomas Zurbuchen, NASA's former associate administrator, called it the strongest evidence yet that Mars once supported conditions favorable to life. These organic treasures are now sealed in titanium tubes, waiting for the Mars sample return mission to bring them home for detailed laboratory analysis that could finally answer humanity's ultimate question. MOXIE. Deep in the Martian wilderness, a toaster-sized machine is quietly performing alchemy, converting the alien atmosphere into breathable oxygen, and proving that humans might actually survive on the red planet without suffocating in 96% carbon dioxide. NASA's MOXIE experiment, or Mars Oxygen In Situ Resource Utilization Experiment, aboard the Perseverance rover, has been working Martian magic since April 20, 2021, splitting CO2 molecules apart and creating pure oxygen at a rate of 5.4 grams per hour, enough to keep an astronaut alive for 10 minutes of normal breathing. This isn't just a cool science demonstration, it's humanity's first successful attempt at living off the land on another planet. The golden box uses a process called solid oxide electrolysis, heating Martian air to 1,470 degrees Fahrenheit and using electrical current to separate oxygen atoms from carbon dioxide molecules. Over 16 successful runs, MOXIE has produced a total of 122 grams of oxygen, more than 4 hours worth of breathable air for a single astronaut. MIT's Michael Hecht, the experiment's principal investigator, described the results as absolutely remarkable, noting that the device has consistently produced high-purity oxygen, despite Mars's wildly fluctuating atmospheric conditions and temperature swings of over 170 degrees Fahrenheit. The implications are staggering. A scaled-up version of MOXIE could produce enough oxygen to fuel rocket engines for the return trip to Earth, eliminating the need to transport massive fuel tanks across 140 million miles of space. Mars is literally providing the life support systems that future human colonists will need to survive. NASA SpaceX. The ghosts of Soviet failure are now guiding humanity's greatest space partnership toward Mars, as NASA and SpaceX prepare to land the first humans on the Red Planet, using hard-won lessons written in the wreckage of decades of cosmic disasters. Elon Musk's Starship program isn't just ambitious engineering, it's the direct descendant of every Soviet Mars mission that exploded, crashed, or vanished into the cosmic void. The failures of Mars, 1969A, the heartbreak of Mars 2, and the seismic discoveries of InSight have created a roadmap of exactly what not to do when attempting interplanetary colonization. NASA's Artemis program and SpaceX's Mars architecture incorporate Soviet-era lessons about atmospheric entry, landing systems, and long-duration spaceflight that cost the USSR billions of rubles and countless careers to learn. The partnership officially began with commercial crew missions to the International Space Station, but the real target has always been Mars. NASA Administrator Bill Nelson and Elon Musk have committed to landing astronauts on Mars by the 2030s, using Starship's 100-ton payload capacity to transport everything from habitat modules to MOXIE-derived oxygen production systems. The Raptor engines that will power Starship to Mars burn methane and oxygen, the exact same fuel combination that can be manufactured on the Martian surface using atmospheric processing technology pioneered by failed Soviet experiments. What began as Cold War competition between superpowers has evolved into humanity's unified effort to become a multi-planetary species, built on the foundation of Soviet sacrifices that almost nobody remembers. That's the untold story of humanity's first Mars missions, Soviet secrets that almost changed history. From catastrophic explosions to accidental landings, these declassified missions proved that our journey to the Red Planet started decades before anyone realized. The courage of Soviet engineers and the lessons from their failures are literally powering today's Mars exploration. If this hidden space history blew your mind, smash that subscribe button and hit the bell icon so you never miss our cosmic secrets. Comment below. Which Soviet space mission shocked you the most? More space facts coming your way, space explorers.